So this is going to be a really short video. This is just showing what you'd have to do on delta math. So delta math kind of skips a step where you're actually given the equation, but you don't have that write it in a times b to the t form. And the question just says, given the following exponential function, identify whether the change represents growth or decay and determine the percentage rate of increase or decrease per unit of x to the nearest tenth of a percent. So it doesn't tell you to write the equation in a times b to the t form, but that is what's going to do the trick to answer the question. So this is what I'm going to type in this time. So this becomes 1300 times something to the x. So that is 1.045. So here I also have to predict if I need nearest tenth of a percent, I need to go to the nearest thousand so that when I move it over to, it's ready to go. So that's why we kind of did the table to start to teach it, and this is just the delta math problems. So I'm going to subtract 1 just like the other page. 0.045 translates to 4.5%. So it's already on growth, and we can tell growth is correct because the base is bigger than 1, and we're going to put in 4.5% here. So just a second delta math problem. So we've seen 2 of them. Here's that one where we don't have the a value shown, so I'm just going to rewrite this one first. So this is 1 times 9 to the negative 2x. Ironically, the same as the last one because 9 to the negative 2 is the same as 3 to the negative 4th. I did not recognize that until I started to do this one. So this is 1. If I type in 9 to the negative 2, based on what I just said, not surprisingly, this is 0.012. And then to the x. So 1 minus 0.012 we know is 0.988. So that's 98.8%. And this is decay, right? Because that number is less than 1. So I would change this. This is a drop-down menu, and you would just pick decay. And then here you would do 98.8. And as soon as you switch this to decay, this will change to decrease just automatically in the program. So that's not something you would have to change. And actually, because I said short video, but you know what? We're going to put on the next problems too, just so that, you don't have a million videos to watch, because I think psychologically that can be tricky. So the second part, the only new thing is you got to write the equation for yourself to start out with. So this is a good review of those functions that we learned in the past few lessons. A deposit of $300 is made into a bank account that gets 4.3% interest compounded continuously. So there's my words that signify, I forgot my A and T, and then I didn't leave myself enough room to write stuff. Then we're going to use PERT, right? P times E to the RT. So when I write this function, I have 300 times E. This is growing, so it's positive 0.043 t. Okay, so if you need to go back, watch one of those old videos if that's a problem. So write an equivalent function in the form a of t equals a times b to the t. What is the basic yearly rate of growth to the nearest hundredth of a percent? So just like we've been doing, we're going to put this in a times b to the t form, and that ends up being 1.0439 to the t. So when I do my subtraction to find my base, and the reason I'm doing this here, 4 decimal places, surprise, is because I need the hundredth, so now I need the 10,000th, so that when I move the decimal over 2, I'm ready to have 2 decimal places left. So probably should have mentioned that earlier. So we're going to move this over 2 now, and we have 4.39% growth. So our next problem, and as I said, I'm doing these kind of quickly because you guys have done so many of these types of functions, but if you go back a few lessons, Ms. Morrow goes more slowly over these type of functions. A microwave depreciates at a rate of 10% per year, compounded quarterly. So there I know that I'm using P times 1 plus R over N to the NT, where N is the number of compounds per year. So here, my function, we are starting with something we don't know. So it says to use the variable P for that part, and then we have 1 plus, actually not plus, right? Or we could do plus. We'll leave it as plus, and we'll do negative 0.10 over 4 to the 4t. So there's my equation. If I retype this in, or type this part in, my p is just in the front. I don't know how much the microwave costs, but that doesn't really impact the next part of the problem anyway. So we just leave it. So we have a of t equals p. The part in blue evaluates to 0.904 to the t. So when we find the yearly rate of depreciation, we're doing 1 minus 0.904, which is 0.096. So move the decimal over 2. We just needed the 0.1% here, so I did 3 decimal places so that we end up with 1 decimal place here. So depreciation is more of a financial term for decay, so that's why we have that word there.